Hi, everyone. Welcome to the CF API on K8s talk. I'm Mike Gresham. I'm the product manager for the CF API on K8s team at VMware.
And I'm Piyali, and I'm an engineer on the same team at VMware.
So today, Piyali is going to give an overview of CAPI K8s release. And then she's going to talk about some key features and differences in CAPI on K8s. I'm going to review the roadmap and we'll end with some useful resources. So I'll hand it over to Piyali.
Great, thank you, Mike, for the overview. So now let's dive into an overview of what you get out of the box for CAPI K8s release. So most of the CF API components that you know and love, such as the CF API server, CF API worker, the deployment updater, and the clock, are all components that run in their own Kubernetes pods in the CF system namespace. There are also some new components, the CF API controllers and the register buddy. We will get into what these components are for in the future slides. Now, first, let's talk about what's different in the CF push workflow. Now, while the final user experience is definitely the same between the CF on BOSH and Diego world and CF for K8s, the implementation and the way CF push works is different in CF for K8s. So the CF push workflow can essentially be divided into two main phases or two main parts, the staging part and the deployment part. So first, let's talk about staging. Staging in the CF on BOSH and Diego world worked with CAPI desiring a staging task to Diego. And the staging task included things such as the build pack and package URL from the Blob Store so that the Diego cell would know where to pull this information from in order to actually build the app. And the actual staging happened in a garden container in a Diego cell in Diego. Now, in a Diego-less CF for K8s world, how does staging occur? There is this new component that CAPI is interacting with called KPAC, which is a Kubernetes native container build service. And KPAC's primary purpose in this flow is to use cloud native build packs in order to build runnable app images. So CAPI provides an image custom resource to KPAC, and then KPAC automatically builds the app and places the image in a configured app image registry. We'll definitely be going through this process in more detail in the next slide. Now, after staging, the next major phase in CF push is deployment. So how deployment worked in CF on BOSH and Diego is that CAPI would desire an LRP or long-running process similar to how it desired a staging task in the staging flow. And Diego would take the LRP, which includes the droplet download URL, for example, as well as various settings such as how many instances of the app is desired and CPU and memory limits. And the Diego cell garden container would actually host this running app and would make sure that the number of instances are the same as desired and that everything is running smoothly. In CF for K8s, since we don't have Diego anymore, where do these app instances run? So similar to the CF on BOSH and Diego flow, CAPI sends the desired LRP request to Irene instead of to Diego. And Irene then spins up a stateful set with all of the information that's in the LRP. And this Kubernetes stateful set manages several pods. And these pods, there's one pod for each app instance that's running for the app. And one thing that you might note is that the Blob Store from the CF on BOSH and Diego, which used to hold the build packs and the packages, droplets, and resource cache, are now replaced by a Blob Store that only has a resource cache as well as a package registry. We'll go over that in more detail as well in a following slide. So now let's deep dive into the staging workflow that we touched upon in the previous slide with KPAC. The first phase is that CAPI sets up the build process. And by this, first, after the post v3 builds endpoint is hit, CAPI actually does a couple things. It first creates an image custom resource. And an image custom resource includes the app metadata, as well as the app source code location, and also a custom builder. And a custom builder is essentially a collection of cloud native build packs that are required to run the app. So all of this information is used by KPAC in order to actually build the app. So the next phase is that KPAC builds the OCI image for the app and places it in the app image registry. We touched upon this a little bit in the previous slide, but I'll go into detail as to what KPAC is actually doing to make this possible. So the KPAC has various controllers for each of their resources, and the image controller for KPAC notices that there is a new image custom resource that CAPI built in the previous phase. So the image controller creates a build custom resource, and this build custom resource includes similar information, the metadata source code custom builder, and the build controller notices that there's a new build custom resource and spins up a new pod, a build pod. And this build pod is what actually does the action of building the app and packages the source code and CNBs into an OCI image that can be run from a container. And the build pod also sends this final OCI image to the app image registry that was configured. After the build pod successfully builds the OCI image, it updates the build custom resource with a status successful, that this build is complete and the OCI image is in the app image registry. So phase 3 is, how does KPAC then communicate with CAPI that the build has been complete and that CAPI can continue with the CF push workflow? So phase 3 is the build process completes with app's OCI image reference being recorded in CCDB, which sets up for the following CF push steps. And how this works is we have a new component, as I discussed in the overview, the CF API controllers. The CF API controller is essentially a collection of watchers, you can think of it as, that watches various KPAC resources and performs actions depending on the events that are being done on these resources. So we have a new build controller, which watches for various status updates in the build custom resource. And once the build controller sees that the build has this succeeded and true condition in the status, the build controller then informs CAPI that the build was successful and sends the final built OCI image reference back to CAPI. And this image reference is then recorded into CCDB in the droplet. So now the droplet, and there was an empty droplet that was created in phase 1. The empty droplet is populated with this final OCI image reference. So essentially phase 3 is about bookkeeping, and this concludes the staging process in KPAC. Next, I'll walk into a new functionality in CAPI, which is performing stack updates in CF for K8s. Previously, this workflow was taken care of by Diego, but now CAPI is involved in making sure that these stack updates can happen so that if there is a minor stack update, the operator can easily perform a stack update without having to wait for a new CAPI release. So in this flow, first, after the platform operator updates the stack using kube control, phase 1 is KPAC automatically rebases the app image. And how this works is KPAC rebases the app image, and there is a new image reference at the end of that staging process in the app image registry. Then KPAC updates the corresponding image custom resource that CAPI has built when the app was first pushed, and updates this with the latest image of the rebased image. And also with a latest build reason of stack. This latest build reason will be important for the next phase. The next phase, which is phase 2, is the CF API controllers auto-deploy the rebased image. So there's an image controller in the CF API controllers. In the previous slide, we were talking about the build controller, but now we'll talk about the image controller. So the image controller sees that the app's image has been updated with a new image reference. And it also sees that this image has been built with the latest build reason of stack. With this information, the image controller then patches the app's stateful set. As you recall, Irene spun up a stateful set for this app previously when this app was first pushed. So the image controller updates that stateful set with the new image reference. And the new image reference now includes the new stack. And with the Kubernetes rolling update strategy for the stateful set, the pods get rolled out one at a time with this new image reference. And this definitely leverages the Kubernetes rolling update and Kubernetes stateful sets. And basically, it is a very hands-off approach and very automated approach in performing the stack update. The final step is that the CF API controllers also does the similar bookkeeping to CCTV to make sure that the droplet for the app is updated with this new stack as well. And there's also going to be a lightning talk demo by me and the PM of the release integration team, Paul Warren, at 2:40. So please come and join us for a demo of this very new functionality. And the final feature I'll talk about is the Blob Store. So as you've noticed before, the Blob Store is definitely looking very different in the CF for K8s world. So let's dive into that a little bit. In the CF on BOSH and Diego world, what was in the Blob Store? Build packs, packages, droplets, as well as a resource cache, which is primarily used for resource matching. There were some pain points associated with the Blob Store in CF on BOSH and Diego. First, there was the S3 compatibility requirement. Then there were some Blob Store specific issues that were pretty difficult to debug from time to time. And the logic to handle the CAPI to Blob Store interactions was pretty complex in CCNG, resulting in numerous edge cases which were pretty challenging to handle. So in CF for K8s, what's in the Blob Store? Only the resource cache, which is used for resource matching. But what happens with the build packs, packages, and droplets? So for build packs, we use custom builders in CF for K8s, and custom builders is essentially a collection of CNBs. And the image for the custom builders is stored in a configured app registry. And for packages, there's actually a new component that I first showed in the overview of CAPI K8s release, which is called the registry buddy. And this registry buddy is co-located in both the CF API server pod as well as the CF API worker pod, and essentially handles everything from converting the source code to a zip file and then to an image, and storing this final package image in a configured package registry. Now, this package registry is an optional component. You can optionally store this in the Blob Store if you prefer. And also, both private and public registries are accepted. So for droplets, we don't have a droplet image per se, because in the full app's OCI image is essentially the same thing as a droplet, which is the app source code and the build packs, but additionally has the stack information as well. So the app's OCI image, as we discussed previously, is built by KPAC and stored in the configured app registry. So now turning over to Mike for the roadmap review.
Thanks a lot, Piyali, for all of that detailed and super informational deep dive on the differences in CF for K8s. So really quickly, I'm going to talk about what's on our roadmap. So the first thing is pragmatic parity, which basically means that we want to achieve parity with the existing CAPI on VM's CAPI on Diego product. And we also want to keep in mind that a lot of things are going to be different now that we're on K8s. So we want to have parity where it makes sense. A great example of this is that build pack administration will now be done outside of CAPI when working with CAPI on K8s. The next thing is we want to surface K8s in CAPI. And there's a lot of interesting information in the underlying K8s infrastructure and APIs. And we want to figure out what will be useful and surface that in CAPI. Great example, Piyali was just talking about stack updates. And so we'll be surfacing information about the stack in the APIs, looking at applications. And finally, I just want to mention that we're always open to feedback. We want to hear, what you think will be interesting about CAPI running on Kubernetes, and we want to hear, what things you're excited about. What can we look into prioritizing? And finally, speaking of, questions and feedback, here are all the different ways you can reach out to us. Our GitHub repos, our Slack channel. We are the CF API on Kubernetes team. And the Slack channel you can find us in is CAPI K8s release. And our interrupt will work in both the CAPI and CAPI K8s release channels. So you can @interrupt and then our channel name, and the interrupt will work in either one of those places on the Cloud Foundry Slack. There's also contact information here for the release integration team, as well as our GitHub repos. And please, please, please join us for our office hours, which will be from 2:40 to 3 p.m. CEST. So we'll look forward to seeing you there. Thanks, everyone.
Thank you for joining us. Okay. Okay, so the first question in the Q&A that we got was, will CF SSH still work in the new CF for K8s world? It doesn't currently work, but Mike has said that there's a roadmap for it.
Yeah, I think the plan is for CF SSH to work in CF for K8s, but it does not currently work right now.
Then I believe there's also a question in the chat. Are there plans to provide a registry in CF for K8s, or will it always require an external registry?
Is this? I'm actually not sure. Like, what kind of registry? Is this?
Yeah,
like
so for the app or the package, right?
Yeah.
Let me also type that follow-up question out in case Ruben missed it. Let me see. I'll start a thread, Ruben, on your question. Oh, okay. Ruben added his question to the Q&A as well.
Yeah.
Yeah, so there are two types of registries in CF for K8s right now for more context around what the difference between the app and the package registry is. So the app registry holds all the OCI images for the full app and for the full runnable app. And the package registry holds the images for just the source code for the apps. So right now, both of those are configurable. And right now, CF for K8s does not include a registry by default, and you configure a registry yourself.
It seems like Yue is saying that she doesn't think there's any plans to have it packaged in, and I would agree with that.
Mm-hmm. Can you repeat the CFSSH answer? Yes, so for CFSSH, it does not currently work, but we will probably have plans for it to work in CF for K8s in the future. And also for CFSSH, we're always trying to gather feedback on like which features are important to work on or implement in the near future. So definitely open up an issue on CAPI K8s release or CCNG about it, and that will really help us track how important this feature is. Can I configure a custom repo as my app registry? Question from Nand. Yes, you can. App registry is configurable in CF for K8s. And it can be either a private or a public registry. Yes. Yes, you can use external harbor as well. Actually, currently we're working on adding even more support for harbor registries with deleting packages. So there'll be a lot of functionality and support for that. And also the CF for K8s GitHub page has some really good details and docs on how to exactly configure it. And there's also a new CF for K8s.io website that you can go to, which is very detailed and awesome. Ruben, to answer your question in the chat, for with my app, do you mean a custom repo per app? I read the Anand's question as a custom registry for the app registry. I might correct me if I'm wrong though, in my understanding of that. Believe we are at time actually for our Q&A session, but happy to stay for another few minutes if anyone has any other questions. So Ruben has asked in the chat, just wanted to clarify because it is a platform setting, not something an end user has control over. Yes, this is something that the platform operator would have control over when they're setting up CF for K8s.
Mm-hmm.
Okay, if doesn't seem there's any further questions and we're a few minutes over, guess we can go ahead and stop this Q&A session. But if you do have more questions or issues or feedback or anything, please reach out to us on Cloud Foundry Slack in the CAPI Kates release channel, and we'll be happy to help you out there.
I think we have office hours a little later today as well, in about an hour.
Yep. Cool.
Alrighty. Thanks, everyone.
Thank you. Have a good rest of your summit.